Greetings and welcome to the introduction to astronomy. In this lecture, we are going to talk about Venus, at least begin our study of Venus, and we are going to look at its geology in this case. So we will look at the surface features and briefly at what we know of the interior. So what do we know about Venus? Well, first of all, it's very hard to see. It is completely shrouded in clouds, so we do not see the surface from Earth and cannot see the surface in visible light. However, we can study it by radar. And here we have a radar map of Venus showing that it looks very similar to Earth. And what I mean by that is that it has some very high continental areas, such as Ishtar up here and Aphrodite in a more equatorial region that look not that different than continents here on Earth, and some very low lying basins, much as you would have in the oceans of Earth. So if Venus were a little cooler and filled with water like Earth, it would not look that different. Certainly the exact outlines of the continents would not be the same, but the structures, what we're seeing, would be very similar. So lava plains make up a vast majority of the surface, and we see no sign of active plate tectonics on the surface of Venus. Now, it doesn't mean there weren't there in the past, and we can come back and look at that a little bit later. We also see mountainous terrain, and I mentioned the two regions, Aphrodite, which is the equatorial region about the size of Africa, and the Ishtar, the polar region, which includes the highest region on the planet. You can see those in the red here. The Maxwell Montes are the highest. Those mountains are the highest at 11 kilometers, again higher than any mountains on Earth. So let's look at some of the features that we see, and this is an overall view. Let's look at things in a little more detail. And what we can see is that craters, there are about 1,000 craters on Venus. Now, as you recall, that's more than on Earth, but far less than we saw on the moon or Mercury. So Venus is an intermediate age. Its surface is not quite as young as Earth's, but is not near as old as that of the moon or of Mercury. We also notice that they are very sharp and fresh looking. They look like they've just formed. Now we know they didn't all just form recently, but this can also be caused by a lack of erosion. On the Earth, we get erosion by wind and water, for example. We don't get that on Venus. Venus has no water, and it's a very still, stagnant, thick atmosphere. So it doesn't even have a lot of wind erosion. But we do know that the surface is relatively young, at least compared to that of Earth. We see volcanic features as well. And in fact, Sif Mons is very similar to the Hawaiian volcanoes that we see on Earth. Here in the radar images, the lighter colored are the very irregular regions that reflect the radar waves very well. Smoother regions will appear dark. So those light regions are probably relatively fresh lava. And in fact, it's still thought that Venus may be undergoing volcanic activity to this day. Certainly, it's been much more recent there than it was on the moon, or as we will see, even on Mars. Now, the volcanoes, though, are not the only volcanic features. We also see some things like pancake domes. And these domes are flows of a very thick lava that spread out in a more even manner. So it's very thick, very viscous lava that expels there. And we also have coronae, which are bulges in the crust where there are stress marks in the crust. And those bulges where lava tried to push out, but could not make it to the surface. So many of these features and a lot of the features that we see, there's a few craters, and a lot of what we see are volcanic features on Venus. Now, how about signs of tectonic activity? As I said, there is no sign of plate movements now. However, there are some craters which have been modified by what appears to be tectonic activity. So craters where it seems like crust has flowed around them or cracked around them. And it's quite possible that there has been tectonic activity in the early history, but that ceased when Venus cooled. So for whatever reason, Venus cooled quicker than Earth. and therefore the activity within it died off a lot faster on Venus than it did on Earth. We also look at those Maxwell Mountains that we see. They look similar to the Himalayan mountains on Earth, which are formed by tectonic activity. And that is material pushing up when two plates crush together and push those up. So maybe there was some tectonic activity on Venus early on. And remember that Venus is an object much closer to Earth in many properties. So it has very many similarities to Earth as compared to the other objects that we've looked at so far. So perhaps it did have some tectonic activity, which we really did not see on the moon or on Mercury. And here we see part of those Maxwell Montes that were formed, again, may have been formed by some kind of tectonic activity. Now, what about the interior of Venus? What do we know? We talked a little bit we knew a little bit about the interior of Earth. We didn't know much about the interior of the moon and had a vague idea about Mercury. How about Venus? Well, what we do know is that Venus has a thick crust compared to Earth. So Venus is much thicker crust. So we know that there's no plate motions, and that the core is mostly solid iron and nickel. So we don't have as much detail here. We know the crust is relatively thick here. We know that there is a large hot core, but we believe that the core is primarily solid and that there is no molten portion to it. That means that we don't get the convective currents, which means that there is no magnetic field. So Venus does not have a magnetic field. And we saw a magnetic field on Earth. We saw one on Mercury, a very weak one on Mercury. So we knew Mercury's interior was partially molten. We say that Venus does not have that because it's much too cooled off. The core is too solid, and there's no chance for those electrical currents to generate the magnetic field through the dynamo as we see here on Earth. So let's go ahead and finish up this portion with our summary. So what we looked at, the surface does have some similarities to Earth with volcanic features, as well as some cratering features that we see there. The overall structure may be overall similar to Earth, but there are a few differences as well. Big difference being that there is no current tectonic activity, so no tectonic plates, but there are some signs that there might have been some activity like this in the past. Now we also note that the impact craters are sharp and fresh. And this is because of a lack of erosion. So there's no water on Venus. And while there is an atmosphere, we're going to see that the atmosphere is very thick and dense, and it has high winds, but only up high in the atmosphere. So that leads to a lack of erosion close to the surface, making the craters appear younger than they would if the similar craters had formed here on Earth. So that concludes this lecture on Venus geology. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.